Hello everyone, so we're back to a new chapters and today topics, and that is water. This is the part 2 of food chemistry, and if you have not gone through part 1, please go through it. The video's link will be given in the description below. So let's start. No, first of all I want to tell something about water is that we all know that water can exist in solid, liquid and gas forms, right? And I'll just mention some data over here that you should know as a experience of food safety officer, right? You know that salt water, it constitutes about 96.5% of total global water. Okay, salt water constitutes about 96.5% of total global water. And talking about fresh water, this fresh water, 30% of fresh water is actually present in groundwater. Okay, so groundwater is a good source, or say a huge source of fresh water. And the water that we consumes, 35% of that is actually derived from food. 35% of water required by our human body is derived from food. Simple as that. Okay, I think that's a good introductions of water. I think we can start. Okay, so what we are going to study today basically is physical properties of water and water activity and hysteresis. So let's start. Okay, so coming to physical properties, we all know that physical properties deals with like freezing temperatures, boiling temperatures, heat of fusion, heat of evaporations, and many more, right? Now we all know that freezing temperatures of water is 0 degrees Celsius, boiling temperatures is 100 degrees Celsius, but what we don't know actually is heat of fusions, heat of evaporation, right? Heat of fusion basically it is what? Heat of fusion means you can understand like this, that it is the heat, okay? Heat of fusion is the heat that is required to change the solid to liquid. No, I mean, sorry, that was that. Heat of fusion means the heat that is required to change solid to liquid. Yeah, I'm right. So what is heat of fusion? Heat of fusion is the heat, okay, that is required to change solid to liquid. Simple as that. And what is the heat of fusion of water? That is 6 kJ per mole. To be more specific, you can say 6.01 kJ per mole. That is the heat of fusion of water. Simple. Okay, going to next. What is the heat of evaporation? As we all know that what is evaporation, right? It is conversion of liquid to gas. So heat of evaporation actually means how much heat is actually required to convert liquid to gas. Simple as that. And of water, it is 40 kJ per mole. To be more specific, you can say it is 40.66 kJ per mole. Simple. Now, heat capacity. Heat capacity of water is 75 kJ per mole. Now, what actually is heat capacity? There is heat required to change an object's temperature. Okay, if you want to change temperature of any object, okay, the heat that you will require to change its temperature is called, yes, it's called heat capacity, and that is 75 kJ per mole of water. To be more specific, we can write 75.33 kJ per mole. Simple as that. Okay, now there is the heat capacity of water. Okay, heat capacity of water is 75 kJ per mole. Then what is the heat capacity of ice? It is 37 kJ per mole, right? To be more specific, you can say 37.85 kJ per mole. Simple as that. Okay, now density. What is density? We all know that, right? So density of water is 0.998 kg per mole, gram per moles, and density of ice is 0.917 gram per mole. Simple as that, right? And the electric constant of water is 80.4. Simple as that. Okay. Okay, coming to the water activity. First of all, you have to understand what actually is water activity. First of all, you have to understand, right? So what is water activity? It is just the water available in food. Okay. What is water activity? It basically is water available in food. We will learn just that one just within few minutes, but as I have given this point before, let's finish this one first, right? Now this moisture absorption isotherm. Okay, what is this moisture absorption isotherm? What is this? Basically it is a graph. Okay, it is a graph that represents percent change in ERH or water activity. Okay, it is it is basically a graph that represents percent change in ERH or water activity. Now what basically is ERH? We all know it is equilibrium relative humidity. Okay, what is ERH? It is equilibrium relative humidity. Means uh you know uh this moisture absorption isotherm basically represents percent change in equilibrium relative humidity. Simple as that. Simple as that. Okay. Now this moisture absorption isotherm, it changes with the moisture level. Okay. What? Moisture absorption isotherm, it changes with the moisture level. Okay. Now, as I said, it is a graph. Now, how does this graph actually looks like? It's like linear, and sometimes it is sigmoid. We all know how is linear, how is sigmoid. Sigmoid is S shape graph, and linear. Here I have the pictures, but yeah, so that is linear, and sigmoid is S type. This here we can see it is straight, right? But in sigmoid it is S type. Okay, I hope everyone knows that. Okay, so uh yeah, so as I have already told you that water activity is all about the water available in the food. And one very interesting fact over here is that water activity is always below 1, or say less than 1. Why, sir? Why water activity is always less than 1? It's basically because this water that is present in the food, okay, it is bound to solutes. That is a food, okay. What? Water that is present in food, it is bound to solutes and surface of the food. Are you getting what I'm saying? I'm saying that the water that is present in food, it is bound with the solutes, okay, or means and surface of the food, because of which this water activity is always less than 1. Simple as that. Okay. And water activity, how can we measure? It is like ERH divided by 100. Okay, ERH, as I have already told you, it is equilibrium relative humidity. To actually quote this water activity in scientific terms, I can say, like, it is basically the ratio. Okay, water activity is basically the ratio of partial pressure of water in food. What? It is ratio of partial pressure of water in food to partial pressure of water. Simple as that. Okay. It is very simple. Just remember that. Okay, coming to hysteresis. Yeah, so what actually is hysteresis? It is basically, okay, sorry for that. It was supposed to be this one. Okay, so yeah, what is hysteresis? It is basically equilibrium differences between absorption and desorption curves. Hysteresis actually, when you plot this absorption and desorption curves, you will you find a place where they both meet. That is called actually hysteresis point, right? So this hysteresis actually occurs, or it can is it is observed in hygroscopic materials. Now, as you all may know that what actually is hygroscopic materials, these are the materials that can actually absorb water. Okay, they can readily absorb water from the atmosphere. Simple as that. This is hysteresis. I mean, this is hygroscopic, and this hysteresis phenomenon is actually observed in these hygroscopic materials. Hygroscopic materials means the materials that can easily, or say readily, absorb water from the atmosphere. Simple as that, right? Okay, that's enough for today. I hope you all understand what I have explained. And if you want to participate in the mock test series, where I take I conduct test series chapter wise, and giving the proper solutions and the reasons behind that. If you want to participate there, I will give it the mock test details in the links given below. And yeah, and you can contact me. Even I will be giving my WhatsApp number. So yeah, that's all for today, and we'll meet in the next video.